This question came up from the 11 Plus Journey Facebook group, where a member posted for some help regarding this particular question. And it reads, what ratio of this shape is shaded to unshaded? There are a lot of people who commented with the correct answer. However, there are lots of different ways in which people approach this, and we're going to talk about the different ways, some which are more efficient and some which are less efficient. And the whole point of this video is I want you to learn why efficiency is important, because usually with efficiency, you have high reliability and accountability. And for the 11 pluses in particular, if you can solve this question in under 10 seconds, let's say, rather than 2 minutes, then that's an extra almost 2 minutes that you can spend on other questions, which could be even harder. And then because we're after a ranking here, if your child is above somebody else's child, then you're better off in the exams. So I'm just going to put this to one side first, and we're going to talk about some I guess the most basic way of doing this is really just by counting them. So you might count 1, 2, 3, 4, 5, 6, and so on. But I think we can all agree that it's not particularly efficient. We can quite easily make mistakes. We can overcount, we can undercount, and we can lose concentration halfway through, and we have to restart the counting again. And then some people then suddenly realize, well, actually, you can actually count the shaded ones like this. So you don't actually have to count all of them. But this way, you know that this must be a 13 by 13 grid. And then all we need to do to add up the remaining ones is to say, well, what's 1 plus 2 plus 3 all the way up to 12? And if you can do the mental calculation, that's great. My mental skills are not that sharp. So I really wouldn't want to do this calculation. And then more shockingly, there are some people who said that, oh, actually, you can use some of the arithmetic sequence. And they produce this formula, or another version of this formula is like this. And that for me is the most shocking, is because this is an 11 plus level question of which really KS2 skills are required. These two formulas are great formulas if you're teaching KS3 or GCSEs or A levels. But even then, I would always teach them so that you understand why the formulas work, as opposed to here, just use formulas. Because the whole point of the 11 pluses is they want to find children who genuinely understand how to think and analyze and assess a problem. So at this point, I actually chimed in and said, look, if you're going to do this calculation, you should really consider trying this method here. And this is Gaussian summation, which is kind of like the foundations of the formulas that I just mentioned. And Gauss was a really smart kid. And he said, well, why don't you just use number bonds like this, and you'll find that you have nothing but a series of 13s. And here you'll see quite specifically, this is the last pair. So this becomes 6 times 13. So you have 6 pairs, all of them equal to 13. And that kind of makes your calculation much more efficient and much more reliable at the same time. But again, I didn't actually solve it like this at all, but you could solve it like this. And then you can work out that you've got to add an extra row for the white ones, and you come up with the correct answer. But I actually didn't do it this way either. How I actually did it was like this. You still have to do some counting because you still need to find out, well, what size grid this is. But I counted this way. I counted like, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, because I picked one on each row or one column, no matter which way you look at it, this must be a 13 by 13. To which in total, there are 169. However, the ones that I actually made a dot on, well, there must be 13 there. So that means if I take away that 13, I get 156 left. This is how much is left after my initial 13 white ones that I took out. Then you'll notice that but the gray or the shaded and the unshaded, well, they're exactly the same, which means if I just simply divide by 2, well, then you can work out that there's going to be 78 here and 78 here, but I've got to add on this extra 13, which means my shaded to unshaded is 78 to 91, and this whittles down to 67. And that's how I actually presented my initial answers. And again, that seems pretty fast. You can do it quite quickly. But then the more I thought about it, there are actually, again, faster ways than my initial assessment. And it goes along something like this. let me just, it runs on the same idea, but just slightly more analytical and less calculation. So I still start off by doing this. I do my dots and say, well, there's 13 by 13. So I still go through the initial analysis. Well, there must be 13 by 13. And my middle section is one lot of those 13s, which means the remaining section, the parts that are left, must be 12 lots of 13, of which they're equal measure again, which means that there must be 6 lots of 13s on each side. So that means my shaded to unshaded, well, shaded would be 6 lots of 13s. Shaded would be not just this 6, but another one there, so it's 7 lots of 13s, which means that the ratio must be 6 to 7. At no point do we even need to do the calculation because, well, why should we? Because we're making the number bigger just to divide it again by the same number. So why bother at all? And this way is probably one of the most efficient ways of doing this problem. If you find a different way or a faster way or a better way, please leave some comments below or message me. I'll be happy to learn because this is just one way which I was thinking about. And I can present, again, you can present it in a slightly different manner as well if you wanted to. Is that if you counted it like this, let's say here we're at row 13, but the analysis remains the same, is that this is 1 times 13, which means that this that's left is 12 times 13, which means when you split it in half again, well, this must be 6 lots of 13, this must be 6 lots of 13, and all the white ones become 7 lots of 13. So again, the unshaded to shaded is 6 lots of 13 to 7 lots of 13, which then whittles down to 6 to 13, 6 to 7, sorry. So just a different kind of visual approach for children who can't quite see the diagonals as nicely, but they should be able to hopefully recognize that the shaded and unshaded just on this section here is going to be of equal measure.